I'm Morgan,
and we're going to teach you about air pressure.
Air pressure is the force exerted by the weight of a column of air above a particular location.
As stated in Charles's law, the temperature of an object increases the air pressure of an when an object increases or expands. During his lifetime, Charles was known for his inventions, including the hydrogen balloon. Today, Charles is best known for his investigations of the behavior of gases. Charles collected data on the relationship between the temperature and volume of gases. When he graphed the data, the graph was a straight line. The graph would show that the volume of a gas increases at the same rate as the temperature of the gas. Charles's law states that the volume of a gas is directly proportional to its temperature in kelvins if the pressure and the number of particles in the gas are constant. Charles's law can be written as a mathematical expression in which T1 and V1 represent the temperature and volume of a gas before a change occurs. T2 and V2 represents the temperature and volume after a change occurs. Right now we're going to look at Charles's law, the equation for Charles's law, which is V1 over T1 equals V2 over T2. By cross-multiplying the two, the equation would turn out to be V1 times T2 equals V2 times T1. The temperature must be expressed in kelvins. If the temperature in degrees Celsius are used in the expression, the volume will not be directly proportional to the temperature.
Robert Boyle, who was born in Ireland in 1627, was the first to describe the relationship between the pressure and volume of a gas. Boyle's law states that the volume of a gas is inversely proportional to its pressure if the temperature and the number of particles are constant. Boyle's law can be expressed mathematically. P1 and V1 represent that pressure and volume of a gas before a change occurs. P2 and V2 represent the pressure and volume of a gas after a change occurs. So, the equation would turn out to be P1 times V1 equals P2 times V2.
Now that we've explained air pressure, we are going to perform our egg in a bottle experiment.
When you think of this experiment first, you would never think that an egg would be able to fit through a small opening, but due to Charles and Boyle's law, it can.
The materials that you will need for this experiment are 2 hard-boiled eggs,
Matches,
a small piece of newspaper,
a small flask,
and tongs to put your newspaper in the flask.
and don't forget to wear your safety goggles.
First, you will begin with peeling the shell off of your hard-boiled egg. Once the shell is completely off, place the egg over the flask. Notice it does not drop in. Then, you'll take the egg off, get your newspaper ready with the tongs, and light it on fire. Drop it into the flask and quickly put the egg over it. Notice how the egg quickly dropped through the opening.
The lit matches heat the air inside the bottle. When air is heated, it expands and takes up more room.
As the heated air expands, some of it escapes out of the bottle. When the matches go out, the air inside the bottle cools and contracts and makes up less room, which creates a lower pressure inside the bottle than outside. The greater pressure outside the bottle forces the egg into the bottle.
The egg is not sucked into the bottle. In reality, it is pushed by gravity. The pressure between the inside and outside of the bottle has changed, causing a stronger force outside the bottle, which results in the pushing of the egg.
Now, students, you will work on some post-lab questions given from the lesson explained. This will be a graded assignment, and you have 10 minutes to work on it. Good luck!